Hey, welcome to Sharkfinger. It's Shadow here, and today I'll be walking you through how to make an advanced 2D platformer controller and how everything in it works. I'll start by explaining how the code works and then get into the code itself. I do want to say before we get into it that you should play around with the values of the variables to get your controller feeling good and how you want the player to control. I'll give some values to those variables for what I think feels good to control, but it all depends on what you think and what kind of game you are shooting for. Also, this tutorial uses the character I set up in my last video, so make sure to follow that if you need help setting your character up. Starting with movement, we need 7 variables. We need a maximum speed the player can move with. For example, do you want the character to have a generally slow movement like in Hollow Knight, or a faster one like in Super Meat Boy? We also need values for how fast the player accelerates and decelerates. This way we can control whether the player's movement responds to input quickly, similar to how movement works in games like Celeste, or whether the player needs to build up and maintain momentum, similar to games like Sonic. Then we need a turn speed value. This is how fast the player's speed changes when they are trying to move in the opposite direction of their velocity. For example, if the player is moving right and trying to move left, they will slow down over time with a slow turn speed, but will change direction almost instantly with a fast one. After those, we get to the air movement variables, starting with air acceleration. This is pretty self-explanatory. It is how fast we accelerate when mid-air. Then there is air control, which is basically turn speed when in mid-air. Finally, we have an air brake value, which is our deceleration when mid-air. In the script, we want to start by deleting everything inside of the class. This is so that we can have a clean space to work from and not have to work around the code we had before. After that, we need a variable to store whether we are on the ground or not, so we write private bool is grounded. Then we initialize our movement variables that I described before. We also want to separate these variables out in the inspector to make them easier to find. We write export category and name the category movement, export public float max speed, export public float acceleration, export public float deceleration, export public float turn speed, export public float air acceleration, export public float air brake, export public float air control, private float direction, and private vector2 vel. In this block of code, the export keyword tells Godot that we want to be able to change the variable's value in the inspector, and the export category keyword creates a new section in the inspector, which the variables that follow it will be held within. We also initialize the variables for what direction the player wants to move in, left or right, and the player's velocity as a whole. Then we want to move our character every physics tick, so we use public override void physics process double delta, and inside it we write is grounded equals is on floor, call a running function and pass our delta variable, velocity equals vel, and finally call the move and slide function. Now, we called a function to calculate the movement of our character inside of physics process, however we did not define that function, so let's do that at the bottom of the script with public void running double delta. First, we want to get what direction to move the character in with direction equals input.getAxis and pass it the parameters of move left and move right. Now, this next block of code handles all the scenarios of how we want to move when accelerating or decelerating, and whether we are in the air or on the ground. If mathf.abs direction is greater than 0, if direction times vel.normalized.x is greater than 0, if not is grounded, vel.x plus equals direction times air acceleration times float delta, else vel.x plus equals direction times acceleration times float delta. Else, if not is grounded, vel.x plus equals direction times air control times air acceleration times float delta. Else, vel.x plus equals direction times acceleration times turn speed times float delta. else if mathf.abs vel.x is greater than 0, if not is grounded vel.x minus equals vel.normalized.x times airbrake times float delta, else vel.x minus equals vel.normalized.x times deceleration times float delta. I'll give a quick explanation on how it works, but feel free to skip ahead if you really don't care. So we start by checking whether the player wants to move the character. If not, then we check if the player is still moving before applying our deceleration, if they are on the ground, or our air brake if they are in the air. If the player is trying to move, then we check if they are trying to move in the same direction they are already moving or in the opposite direction. If it is in the same direction, we apply our acceleration or air acceleration as normal, but if it's in the opposite direction, we also apply our turn speed or air control, again depending on whether the player is in the air or not. Finally, we don't want the player to reach near infinite speeds, so we cap their speed with if mathf.abs vel.x is greater than max speed, vel.x equals vel.normalized.x times max speed. Also, don't forget to put the condition in the parentheses like I did. Now save the script and go back to Godot. You want to make sure you have the player node selected and then click the hammer button in the top right. There should now be a movement section in the inspector. For now, we want to set max speed to 300, acceleration to 100, deceleration to 200, turn speed to 2.5, air acceleration to 100, air brake to 200, and air control to 0.5. Now for what is arguably the most important part of any 2D platformer, the jump. In this section, I will also go into some of the assists that developers add into their game to help the player in hidden ways. We start with a value for what velocity we want to jump with. It should be pretty easy to figure out that the higher the value, the higher you jump. Next, you may want to tweak gravity so that the player falls faster than what gravity would normally cause. To do this, we apply a multiplier to our vertical velocity when the player is falling. That way, they accelerate downwards faster when falling than they decelerate when jumping. There are some games like Hollow Knight that use a variable jump. That is, a jump that holding the input allows you to jump higher than if you just tap it. Now, the first assist developers usually add to help their player is called Coyote Time. It gets its name from old cartoons, especially the old Roadrunner cartoons, when the ground would fall out from under a character, but the character would stay in the air for a short time before falling. In video games, this could mean the player doesn't start falling until after a few frames they have been in midair, or it could mean they can jump in midair for a few frames after leaving the ground. In this tutorial, I will be showing you how to do the latter of those two. After that, we have the jump buffer. Let's say the player presses the jump input a few frames before the player is on the ground. The jump buffer remembers that input for a short time and jumps when the player is able to. Sometimes, the player has to fall for a long time. You still want them to be able to react to what is below them instead of slamming into the ground at Mach Jesus. To do this, developers set a terminal velocity that they cap the player's downward speed to. Back in the script, we need to add another block of variables for our jumping mechanics. Near the top of the script, we write export category and name the category jumping, export public float jump velocity, export public float down molt, export public float variable jump, private float gravity, private float jump time. We also need a block of variables for the assists we give the player, so we write export category and name the category assists, export public float coyote time, export public float jump buffer, export public float terminal velocity, private float C time, private float JBuff. Just as some extra explanation on the variables, we will be using jump time to know how much jump we have left when using variable jump, C time as our timer for coyote time, and JBuff as our timer for our jump buffer. Now we have to set our initial values for jump time and gravity when the player loads in with public override void underscore ready, and then inside it we write jump time equals variable jump, and gravity equals float project settings.get setting, and pass it the path physics/2d/default_gravity. Then inside of physics process, we call our jumping function with jumping and pass it the delta variable. Now we define our jumping function at the bottom of the script with private void jumping double delta. First, we count down c time if the player is in the air, as well as apply gravity normally if they are moving up, and the multiplied gravity if they are moving down. We also reset the player's vertical velocity, jump time, and c time when they are on the ground. We do all this by writing if not is grounded, c time minus equals float delta, if velocity.y is greater than 0, vel.y plus equals gravity times down molt times float delta, jump time equals 0. Else vel.y plus equals gravity times float delta. Else vel.y equals 0, jump time equals variable jump, c time equals coyote time. Then we cap our downward velocity with if velocity.y is greater than terminal velocity, vel.y equals terminal velocity. After that, we let the player jump if coyote time is in effect. If not is grounded and c time is greater than 0, is grounded equals true. We then work our jump buffer with jbuff minus equals float delta. If input.isAction just pressed jump, jbuff equals jump buffer. Then we jump if our jump buffer is active and the player is on the ground. If jbuff is greater than 0 and is grounded, vel.y equals negative jump velocity, jbuff equals 0, c time equals 0. Finally, we write the logic for our variable jump. If input.isAction pressed jump and jump time is greater than 0 and not is grounded, vel.y equals negative jump velocity and jump time minus equals float delta. Now save the script and go back to Godot. Make sure you have the player selected and click the hammer button in the top right. After it's done building, you should see two new tabs in the inspector, one for jumping and one for the assists. For now, we will set jump velocity to 400, down molt to 2.5, variable jump to 0, coyote time to 0.1, jump buffer to 0.1, and terminal velocity to 1000. There are a number of ways you can build a camera controller. Some, like Super Meat Boy, don't even require code for the most part. Because of this, I'll be showing you how to make a nice character controller that follows the designs of the majority of 2D platformer controllers. First of all, we want to set a position for a camera relative to the player. For example, this allows us to have the center of the camera be a small bit above the player. In some games, it is important to be able to see what is ahead of the player. The first way to do this is to change the zoom of the camera, and the other way to do this is to have the camera move ahead of the player in the direction they are moving. When the camera is moving, you probably don't want it to just instantly snap its position to where you want it. Instead, you want it to gradually move towards that position. This is where damping comes in. Have you ever flicked one of those spring door stops? Well, as it moves back and forth, it slows down until it comes back to a rest. That slowing down is it damping its movements. Finally, there are times when you don't want the camera to move up or down when the player is mid-air, so we will add the option for the camera to only move its vertical position when the player is on the ground. Back in the script, we start by creating another block of variables for controlling the camera. We write export category and name the category camera, export public camera 2D camera, export public vector 2 base pose, export public float zoom, export public vector 2 damping, export public float look ahead, export public bool ignore jump, private float camder, private vector 2 target pose, private float last ground pose. Then we set the camera's initial position and zoom inside of ready with camera.globalPosition equals global position plus base pose, camera.zoom equals new vector2 zoom zoom. Next, we call our camera function inside of physics process with camera and pass it our delta variable, after which we get our value from camdir inside of our running function with camdir equals direction. Now we define our camera function at the bottom of the script by writing private void camera double delta. We start by updating our last ground position if we are on the ground. If is grounded, last ground pose equals global position.y. Then we calculate our target position on the x-axis with target pose.x plus equals open parenthesis camdir times look ahead minus target pose.x close parenthesis divided by damping.x close parenthesis times float delta. It is very important that the parentheses are like this, otherwise the formula will be messed up and it probably won't work right. After that, we calculate the target position on the y-axis using the player's velocity if ignore jump is turned off, then move the camera to the correct spot. If not ignore jump, target pose.y plus equals open parenthesis velocity.normalized.y times look ahead minus target pose.y close parenthesis divided by damping.y close parenthesis times float delta. Camera.globalPosition equals global position plus base pose plus target pose. Otherwise, we calculate the target position on the y-axis using the last height the player was at when on the ground and move the camera accordingly. Else, target pose.y plus equal open parenthesis last ground pose minus target pose.y close parenthesis divided by damping.y close parenthesis times float delta. Vector2 pose equals new vector2, pose.x equals global position.x plus base pose.x plus target pose.x, pose.y equals base pose.y plus target pose.y, camera.globalPosition equals pose. Finally, save the script, go back to Godot, make sure the player is selected, and click the hammer button in the top right. There should now be a tab for the camera variables in the inspector. First, drag the camera from the scene tree to its slot in the inspector. Then we will set base pose to 0 on the X and -20 on the Y. Then set zoom to 2, damping to 2 and 2, look ahead to 50, and we will leave ignore jump off for now. Now, if you save the scene and run it, you should have a fully working 2D character. As I said before, you should play around with these values and change them to something that feels good to you and works with the game you are trying to make. After making the character, the next logical step is to build a level for that character so you can see exactly how it plays. Anyways, thanks for watching. If this tutorial was helpful, leave a like. If you want to keep up with any other tutorials I put out, consider subscribing. So see ya and have a good day.